I would now like to welcome to the floor our next speaker, Gianlorenzo de Santis, Industry Liaison and Operations Executive at Crover. Gianlorenzo has a keen passion for the complexities of the agri-food system and for improving the efficiency of its value chain through innovation in all forms. He holds an MSc in food marketing from the University College Cork. In addition, he focuses on the topics of consumer behavior, supply chain innovations, and novel foods. Recently participating in the research summer school, Insects as Food and Feed. He is here to speak to us today about the need for middle stream technological innovation for a sustainable food system. Gianlorenzo, fantastic to have you with us. The floor is yours.
Very much. So I'm going to talk today about the importance of middle stream solution and the drivers that are behind them. So we are all aware that we need a systematic change to the way that we produce food, the way we buy and we eat food. So if we want to, for creating a sustainable agricultural food system, while still not exhausting the planet resource and in the long term nourishing an increasing world population. To support these changes in Europe, the main plan is to employ what is being called the farm to fork strategy. This strategy, or better, a bundle of strategies, aim to address these challenges and deliver co-benefits for the environment, health, society, and economy. Around 10 billion euro have been dedicated to research and innovation, so to accelerate this transition to a sustainable and inclusive food system. However, these strategies are at the same time bottom and top heavy. That's to say that consumer as much as producer are put at the core of this comprehensive food agenda. On the consumer or on the producer sides, most of innovation falls under the umbrella of precision agriculture. They can take many forms of shapes. You can have autonomous GPS-enabled tractors and sprayers, but also drone and small field robots with added machine vision analytics for weed control and precision irrigation, array of sensors for plant and soil health, and yield monitoring and prediction based on satellite data. On the consumer side, the fork part of it, there are a lot of technologies that focus on behavioral changes, improved consumer choice, and novel purchasing method, as well as novel food and plant-based formulation, and the exponential growth in the interest of personalized nutrition, which is something that other speeches today have touched on. In my opinion, there is as much attention needs to be given also what is like to call middle stream solution. That if we look at the entirety of the agri-food chain makes the bulk of the system component. If the strategies, the farm to fork strategy wants to be successful, they need to put the same attention to the two parts of the chain as much as the fork and the farm. So in middle streams technology, this is the definition I give, and I include in this definition all those novel technologies that are applicable to all the in-between steps that ensure that food reaches people's table. So let's say from farm gate to retail. These include blockchain, IoT solution, machine learning, and quality and environmental sensing technologies. This can improve the safety, the efficiency, and sustainability of the agri-food value chain and increase consumer trust. Another term that is used and often used to categorize these technologies is food supply innovation, food supply chain innovation. But in my opinion, this term is very limited and has very narrow connotations. So I personally prefer using the term middle stream. It's just a little semantic difference, but the latter better capture the interrelation of all the elements in the system. The drive for the adoption of these technologies is multifaceted and has both upstream and downstream components. First, there is the push derived from the need from the producers, because long gone are the times when a product was out of the gate, out of the farm gate, and therefore out of the mind. Producers want to have more visibility of the whole chain, so to create more stronger connection with the end customers. In this way, data can trace back to them, so they can plan better the growing season and be more prepared to seize opportunity of consumer trends, but also to protect themselves against disruption in the food system. This is reflected practically in the continuous and rapidly increasing verticalization of agri-food chains. And at the forefront of this process, there are agri-cooperatives, which are putting enormous effort and investment into innovation and integration between all parts of the chain. Also, agricultural producers don't want to see all this effort that they're putting in innovation and sustainability get squandered by an inefficient supply chain, as every little bit of food that gets wasted means also that they're wasting all the inputs and our work that they put into producing it. This also aligns with the need of the players in the middle portion of the chain, logistic, traders, and processor, which have an increased demand for automation, improved data stream, labor efficiency, and transparency, which is often driven by policy. The COVID-19 crisis has highlighted the need for a more resilient agri-food chain, and we witnessed sudden changes in consumer habits that disrupted value chain and logistic operation, and the impacts of this we are still assessing. This is Alice emphasizes some of the inefficiency of the and shortcomings of this portion of the value chains, such as lack of technologies and labor volatility. So technological solutions are key to reinforcing the resilience of the system. For example, one substantial upset of the farm-to-fork strategy is the reduction of pesticides and pest control substances, which led the majority of food producers in Europe, food producer and traders association in Europe, to produce a bundle of joint letters in which they highlighted their need for substantial investment in research, innovation, and in the development of new tools throughout the agri-food chain, as well as the necessity to keep investment flowing into this area. On the consumer side, basically all the food consumer reports and researches in the last probably 5 years or more put a lot of emphasis on, in a way or another, on the fact that consumers are increasingly wanting sustainability in the product. However, they are also getting more and more dubious about shady sustainability claims, and they are becoming more aware and more contempt about greenwashing. So sustainability and transparency need to go both hand in hand so that they can be the sustainability claim can be substantiated with proof. The solution that is currently gaining a lot of attention now is to provide the transparency through various labeling system that certifies sustainability, impact, social responsibility. But I have a background in consumer behavior. I can tell you that the last thing that consumers want is yet another label. There is already an oversaturation of labels and certification, and label fatigue is a real occurrence. It's something that happens. And what consumers are asking for is for a whole chain transparency that goes beyond of the limited heuristic that a label can give. This is easier said than done because of the complex nature of the agri-food chain. While preparing for this presentation, I was thinking how to categorize these middle stream technologies. A simple solution could be dividing them in digital versus hardware. But then I realized that this is a false simplification because all these technologies mixes to various degrees these two domains. So a better way to understand them is to put them on a digital hardware continuum. On one side, we have predominantly digital technologies, such as AI and machine learning for forecasting and improving the efficiency of operation, digital system for the whole chain quality assurance and sustainability checks, blockchain both for traceability, but also for streamlining contractual flows and transactions. One example here is the Convactis initiative, which is backed by the biggest player in the grain trade, which aims to replace, in their words, outdated, inefficient post-trade processes with a secure blockchain-based digital platform. In the middle, we have hardware and digital mixes, such as the IoT network solutions that makes 4.0 food production a reality. There can be novel sensors that are being implemented at all steps of the distribution. An example here is a miniaturized application of NIR sensor for both inline monitoring, but also for handheld device. And other examples are smart tags and labeling, which not only trace the food product, but also monitor and assess its freshness and quality. One example of this is what our friends at Santis are doing. They have these tags that can trace in the cold chain, food cold chain, from production to shelves, a food product. Then on the other side of the scale, there are robotics automation systems that are applied not only in what are now almost traditional areas like logistic and warehouse automation, but also new areas such as drone used for plant monitoring or deliveries, or robotic monitoring system for harsh environment, like what we are trying to develop at Crover. As we said, we cannot obtain true transparency if all the steps of the chain are not visible. This is what we are trying to work on Crover, to expose those hidden steps. In this case, of the grain supply chain, they are represented of the grain storage phases. Grains are the cornerstone of our global food system, and they are key inputs for almost all the other food subsystems. And storage is an essential midstream stage. It happens at every step of the chain, and it ensures safety and quality of the grains, but it's still the post-harvest phase with the most losses. And however, there is still no way to monitor what happens inside grain bulls while they're still stuck in storage, making silos and sheds like a black box of grain. Our solution is the Crover, is the world's first underground drone. We're developing it with the aim to autonomously scan and sample grains in bulk storage, so to provide early detection of potential spoilage, allowing grain storage operators to reduce losses and maintain quality while improving the health and safety of grain storage operators. We will no longer require to physically walk on dangerous grain bulls. The system that we are developing not only will be able to keep the crops and investments safe by monitoring grain, but also we want to enable grain operators to pass the trust, sharing this data along the chain, supplying their buyers and assurance schemes with the confidence of the safety of their operation. This data flow up and down of the chain brings me to my next point, which is the major barrier of middle-stream technology adoption. So without a common language, this flow of data upstream and downstream gets filtered, blocked, and doesn't reach all the actors involved or the consumer. So what we need is harmonization. Without harmonization among the many components that build such a complex system, also defined as system interoperability, pieces of the chain cannot talk to each other, thereby endangering one of the main benefits of this huge amount of data, which is the possibility to exploit it on multiple sources and providing integrated analysis of complex phenomena. So to identify shortcomings and bottlenecks in the value chain that needs to be addressed. Thankfully, there is some awareness from policymakers in this field, and there are a few attempts to solve this issue. Hopefully, we will be able to witness soon some proper data harmonization framework in the near future. Another key point is data security and data protection, and data ownership also. Our data ownership is our sore spot for middle-stream technology adoption, and not only the technology developed in this field needs to have an extremely high level of data protection and security built in, but it also needs to be very clear about how this data is processed and for what purposes. However, there's still quite a strong reluctance from many value chain actors to share the data. And probably the only solution to this barrier is to create more integrated, shorter supply chain that thrives on trust and collaboration. There are also further barriers to middle-stream technologies, but these are barriers that are not just specific to this technology, but they're shared in general with all the other type of food innovation, which is preparedness for technological change, part of the organization, benefit awareness, communication, know-how and skill, and benefit and cost relation consideration. Even if there is not too much discussion regarding what we talk about until now in the public domain, luckily the investment environment seems to have acknowledged this middle stream solution needs. In 2021, we witnessed a surge of investment in these technologies. And while e-grocery was still at the best funded category, middle stream technologies were just seconds with overall values of $3 billion. Hopefully, this will translate also in an increased public awareness and discussion of these seemingly hidden steps of the agri-food value chain. So to conclude, I hope that in the near future, systematic adoption of innovation at every step of the value chain and all parts of the agri-food system will contribute to the same goal. It will create a situation where whatever choice a consumer can make, regardless of their food decision, will be a sustainable one. Thank you very much. I'd be happy to get in contact with any of you if you have questions. I'm probably gonna need to run now. I will not be able to participate in the panel later, but the great folks at DKA can collect questions, and I'm sure they will send it to me if you have anyone. And you can also contact me on my contacts here. Thank you very much.
Thank you so much, Gianlorenzo. I will ensure that any Q&A questions that come through to you are forwarded duly to you and relayed back to those who were asking today. So thank you so much.
Pleasure to be here.
Likewise, the pleasure is all ours.